Hello, and welcome to the first ever Bowlcut Studios devlog for MageQuit Dungeons. If you didn't know, we're working on a co-op roguelike sequel for MageQuit, which is a top-down wizard brawler. I'm going to start by talking about the dungeon generation work I did in February, show some gameplay, and then turn things over to Chad to show us his progress on weapon and environment modeling. Up until February, our combat has been entirely island-based, which has been really fun, but we wanted to create a room-based dungeon system. So that's what I worked on this past month, and I will get into that now.
Okay, so we start with one giant room here, and then we use binary space partitioning to break it up into smaller and smaller rooms. Okay, so there's this first line here that split it down the middle. Get another one splitting down the middle. Okay, and then this one splits this room horizontally. And you just continue this over and over again until you have a bunch of smaller rooms. Okay. Now, typically the next step is you would do something like this, where you would shrink down each of these bigger rectangles into smaller rectangles and then connect them with corridors. But there's a few design reasons why we don't want to do this with MageQuit. One of them being that the camera, we have a shared camera, and we don't want to have a bunch of dead space that's being wasted on the camera. So we're trying to use as much of the grid space as possible for gameplay. On top of that, the combat in MageQuit is slow and methodical. And if the characters are moving slowly, it's going to take a long time to walk between rooms. So there's a lot more downtime if we were to do something like this. So instead, what we do is we create single wide walls between each of these rooms. And then we also decide what sort of room generation technique we're going to use for each room as we go through these. Okay. So like, for example, this one's going to be a lava cellular automata room. This one's going to be a cave cellular automata room. These ones are going to use wave function collapse, which we'll get into next. The next step is to figure out how to connect these rooms. And the algorithm that we landed on is called Euclidean minimum spanning tree. And the way that works is we take the center of each room and we connect the two closest rooms, and you just keep repeating that until everything is connected. And so let's go ahead and do that. So these are the two closest rooms. Okay, those are connected. And now we want to add a door somewhere on this wall between these two rooms. Okay, well, there's our random position for our door. Okay, so you just repeat this over and over and over until every room is accounted for. And what's really cool about this algorithm is it's guaranteed to connect every room, and it will also create no loops, which is ideal for our scenario. The first room type that we made is a cave room, and we used cellular automata for this. Cellular automata is really good for generating natural looking caves or islands, which we actually use for islands already. So I just wanted to adapt our island generation code to work for caves. The downside of cellular automata is typically it's hard to control. You can't necessarily make it connect to certain points or generate a certain way. But we sort of figured out a way around that. So the first step in cellular automata typically is you create a noise map. So here we can try a bunch of different ones. So essentially you just assign each point on the map to either wall or ground. Okay. Which this just looks like noise. It's not very useful, but the next step is what makes it useful. The next step will take the state of each point and change it based on the state of the neighbors around it. So for example, this one is currently wall, but let's look at each of its neighbors. Okay. Not wall, wall. These are not wall. And then we have one wall here. Okay. So that adds up to, there's only two walls. And the way it works is if there's fewer than 4 walls in the neighbor, this would change to ground. If there's more than 4 walls, then it will change to a wall, even if it's not a wall. So that's typically what you do next. But in our case, we actually carve paths to the center of the room like this. Okay. And then we add a 4x4 block of ground to the middle just to guarantee that the center of the room is open. Okay. So there you go. There's our 4x4 grid. And then we do the neighbor step that I was talking about, and we do it 3 times. Okay. So 1, 2, 3. Okay. And then we actually use Dijkstra's algorithm to figure out that these points are unreachable, and then we also cull those. So we end up with a nice little cave on the side of the room. Additionally, we go back and we carve the paths again because cellular automata doesn't guarantee that those paths will stay there because they're single wide, and the neighbor rule actually can get rid of them. But what's nice about doing it before and after is that doing it before kind of encourages the noise map to create something that kind of fits along those lines. So we can try some other ones and see how they go. That's kind of a cool one. Yeah, it's a little bit bigger room. Okay, ooh, that one's got a nice fun shape to it. Our next room type uses the same method, but we also add lava. So it actually uses a second layer of cellular automata to determine where we want to put our lava. So let's go try that one out now. Okay. All right, so we'll just hit play and see how it looks. Okay, so same idea, except what we did is with the noise map, we actually made the percent chance for lava to be higher than the percent chance for a wall. That way, it's likely that the lava sticks out from the wall. Okay, I actually want to try the seed from the last one we just did and see if it shows up the same way. I'm curious. Start over. Nope, it didn't. I was hoping for that cool shape, but that's okay. We'll try some other ones, see how it goes. That's a pretty cool one. Ooh, this one has a little puddle in the middle, and you'll notice that it carved the path right through this line. We had this little inlet of lava here, and it carved a path right through it at the end. So the rest of our room types actually use an algorithm called wave function collapse, which I will explain now. Okay, so the easiest one to understand would be this one. So the idea behind this algorithm, or we're using texture-based wave function collapse. There are other kinds, but for our purposes, we're just going to be talking about texture-based. And this one uses n equals 2, which means we carve our pattern up into smaller chunks of 2 by 2. Okay, so if you look here, you see, okay, we've got this 2 by 2 here. It shows up here. The next one is here, shows up here, and it loops through. And we actually loop on the sample. So if you want to imagine this lava line here and here showing up on the outside here, and then that's how you end up with patterns like this one, and this one. Okay. One thing that's cool about wave function collapse is that you can preset some values and then let the algorithm generate around them. So we did the same path carving that we did for cellular automata. So you can see those here, and then yeah. So let's just hit play and see how it goes. Okay, it's a pretty cool looking room. The idea behind this room is it kind of creates a bunch of narrow pathways through the lava. So you'll notice that each of the 2 by 2 chunks in here, they all exist in the 12 patterns here. And that's essentially how wave function collapse works. It'll create an output image that is locally similar to the input image that you give it. Okay, so let's take a look at how this might look in game, actually. All right, so this is actually how this room looks in the game. You can see there's sort of continuous chunks of land, and then we have a nice path of lava through the map. Okay, what's cool is we can use the same exact pattern, but swap out lava for walls, and then you end up with a room that looks more like a series of tunnels, which could be interesting. All right, let's look at some other patterns in the visualizer. This is a little more complex pattern, still using n equals 2, but you can see it has 3 different types of environment, and it churns out 23 patterns. Okay, so let's hit play and see how it goes. Okay, that's a pretty interesting one, and you'll notice this piece right here got culled by the Dijkstra culling. Let's try another seed, see how it goes. Okay, that's a pretty cool room. Another one. Oh, this whole bottom part's going to get cut. Okay. Oh, that's a fun one. So I actually built an MS Paint style pattern drawer, so we can take a look at that now. Okay. All right. Well, this is all walls to start, so let's fill it with ground, and then we'll draw a nice little loop of lava in the middle, and we'll set N to 3 and see how that goes. Okay. Try another seed, see how that looks. Okay, yeah, that's a good one. So what's cool about this one is it kind of generates rivers. Let's try a different pattern. We'll go 12 by 12, fill it with lava, and we'll draw some floor through it. And maybe let's put some walls somewhere. Here. Let's see how that goes. Okay, different seed. Okay, that's enough about the individual rooms. Let's go back to the overall dungeon and see what else we still have to do. Okay. So after this plays through the individual steps of the individual rooms, we get to a point where we need to decide where people are going to start in the dungeon and what room they're trying to get to. So let's back it up a little bit. Okay. So the room we actually pick, we pick a room that's on the left, has a leftmost wall, and then we actually just choose the smallest room that there is. Okay. And then we use Dijkstra's algorithm to count the rooms away from the start room. Okay, just like that. And it turns out that this room is the furthest away, and so this becomes our end room. So this dungeon generation is great and all, but we need to make sure that the gameplay is actually fun with the MageQuit style combat. So let's go do that now. We start by dropping the player in the start room. This is one of the wave function collapse rooms. It's going to be on the leftmost side. It's the smallest room. Okay. And you may have just noticed there was a fog shader that animated when the room was entered. So normally we actually use a quad, just a black unlit quad above each room to mask them out. And we're able to do that because we're using binary space partitioning. So each room's bounds is going to be a rectangle. So simple enough just to cover the room with a quad. And then the wall shader is a gradient that goes to pitch black. So you actually can't see where the edge of the room from the walls meets up with those quads that go around the room, which is great. So these enemies do a lot of damage, but they don't have a lot of health. So and since the pet isn't super good at dodging, they're kind of deadly against the pet. But we got that one before he died, so we're good there. Okay, it's another wave function collapse room. This is the grid one without the walls. Another thing we were trying to figure out design-wise is if we could actually leave the doors open during combat. It was fun in theory, but the problem is what ends up happening is the player has kind of an optimal there's an optimal strategy of just opening a door and retreating, and so like you can take the least amount of damage if you do that, but it ultimately ends up not being that fun. So there were a few other design reasons why we ended up ruling against that, but yeah, now we lock everybody in one room together until combat's done. And then as you see, the doors that you've been through before will open back up, and that shader kicks in, and you can see the fog. You can see the fog dissipate throughout the rest of the dungeon that you've already been through after you finish a room. And maybe you'll notice this room, well, this is a dead end, so I definitely went the wrong way. But yeah, the room we were just in was the tunnels room, also wave function collapse. So now we need to backtrack. We're trying to figure out... Oh, that's a bug. Okay, so I definitely need to make that more robust. The problem is, the way it's coded is if the player walks into the door zone, it just takes their position and the difference between the door and then adds it twice to their position. But if you get too close to the door before that triggers, then the pet ends up just maybe not making it through, and you end up with that kind of situation. Okay, so this room is just a regular cave room. We have another wave function collapse room now. And this is another, it's not a bug, but it's something I need to adjust. These enemies pick up small enemies and they'll shoot them at you. But there are no small enemies for them to pick up. So they're just kind of sitting ducks. And hopefully this is the last room. Yep, there it is. There's the chest. Awesome. Okay, yeah, so now Chad is gonna go through the stuff that he worked on this last month, and I guess I'll see you guys next month.
Here's a mock-up of the different cave environment assets that I've made. This is in Blender, and then I'll be bringing these into Unity soon to recolor them and to add cell shading. So the first asset I want to go over are these small rocks here. They can either go along the wall or they can go in the middle of the ground to look kind of like pebbles. Got some wall crystals that can also be added onto large rocks. Got some roots / spikes that go along the walls that help tie the room together with the walls. Here are some cylindrical rocks that can be rethemed for different stuff like poison water down the road. Here are some crystal rock formations that I think help fill the corner. And then there's another one, or a couple more as well along the other side of the wall. Love those stripes. Okay, so here are the same assets added into Unity. The crystal portions are a lot more, or they glow a lot more to help draw more attention to it, whereas the rock portion is a little bit more subtle. In Blender, it definitely stuck out more, which I think would be too distracting in game, because I want the focus to be mainly on the spells and the characters. Yeah, the tube rocks definitely stand out more in that shader. Here are some spike rocks with some crystals attached to it. And then here are some pebbles, which I was going to have on inside the rivers within the dungeon. Okay, here are some characters that I've made. This is the Hive character, and I wanted to showcase a couple of the shaders on it. So right there, you got a waterfall shader and a twirl shader in the middle to make it look like a whirlpool. These are the cluster golem, melee golem units, which like you can see how many eyes it has to showcase that when it dies, it spits out 3 of those smaller versions. Here is the range version, and then there's the mage version with the 3 eyes there. And this is one of my favorite units that I've made. This is a unit that puts other units inside its cannon backpack and shoots them out. And I wanted to show the bottom of it because you don't get to see many unit bottoms. Here's another one. I really like this floater. Very cute. And then the pet unit has a cute little stripe underbelly as well. Okay, so here are some of the weapons that I've made. This is the air staff. Kind of looks like a birch tree branch with some fall leaves on it. This is the fire staff, which kind of looks like a fire poker with spikes on it. And this is the water staff, which has a trident shape on it, and then has a like fantasy tree branch holder portion with some seaweed wrapped around it. This is the rock staff. It's made to look kind of like those rock enemies, but I will probably recolor it to make it look a little bit more earthy. And then here's the air ultimate staff. The shape of it's meant to look very pointed and dangerous looking, because the ability has a very narrow skill shot. It does a lot of damage. And then also has those leaves on it because the abilities have leaves within them. Okay, what's next? Okay, here are some more weapons. So here are a bunch of different colored scythes. Got a club here. I don't know if all of these weapons will be used, but just a bunch of different concepts that I've done. Got a battle axe, spear, trap, crossbow. And we got a big punching glove, which is currently in the game. And then we also have what looks like kind of like a Wolverine, I don't even know, glove dagger thing. Okay, so then I'm gonna show some different dagger and sword assets. Wanted to showcase that they look pretty cool in different colors, and then one thing I like about it are the highlights within the blade portion of it. So those are kind of like those aren't real highlights; they're faked in there. And then a couple other characters. So in MageQuit original only had hair as the beard, but on the unit it has it on the bangs, and then this unit has it on the armpits, which I thought was funny. Okay, so here is the lava boss character. Was going for a like spider crab lava version. I think the amount of eyes and teeth and spikes make it look pretty terrifying. Yeah, and that's pretty much it. Thanks for watching our very first devlog. If you enjoyed the format or have suggestions, please let us know in the comments so that we can keep improving these in the future. There are 3 things I'd like to mention. First, if you like the video, please like and subscribe. 2, wishlist MageQuit Dungeons on Steam, so you'll be notified when the game comes out, and then also it'll help get more eyes in the game when we launch. And then 3, if you want a deeper dive into the dungeon generation stuff, or just want to support us, check the link in the description below for that as well. And then, speaking of patrons, this video would not have happened without our existing patrons, so here's a special shout out.